Welcome back, everybody, to another Swift programming language tutorial. This is part 10 of our basic series, and in this tutorial we're going to go over sets. A quick definition. Sets are unordered collections of unique elements. Sets can be useful when you only want to work with unique values. Order does not matter, and you need to test for membership. So to create a set, we can use syntax that looks like this. We have two examples. In our first example, you use your reserved word or keyword var, then you give your set a name, then you use a colon, and after the colon, type out set, and then you put your type in a pair of angle brackets. So this set is of type string. Then we use a single equal sign for assignment, and then we put our set elements here inside square brackets. Our second example is very similar, and you'll notice the main difference is that we did not explicitly state the type. So this is a set of integers. Okay? To create an empty set, we can use this syntax. So once again, you use your reserved or keyword var, give your set a name, use a single equal sign for assignment, then type out set, and then inside the angle brackets put your type, and then remember at the end put an empty set of round brackets. Okay? So that is the syntax to create an empty set. Now let's use that empty set and let's insert an element into that set. So to do that, we can use this syntax, reference your set, then you use a dot, then you use the insert function, and inside the round brackets you put your element. So if we run this, we're going to use a print to display the contents of set 3. And you can see down here in the console that set 3 now contains the element greetings. Now, as we mentioned in our quick definition, sets contain unique elements only. So we have created an array, and you can see that several of the elements are duplicates. And to get rid of those duplicates, we can just simply take that array, name, and then wrap it in a set. And let's go ahead and display the contents now. So let's run our code. And this array should now just contain A, B, and C. And you can see it does down here in the console, even though it's unordered. Now if you wanted to sort that, let's see if we can do that. Let's see if we can use sorted. And that does appear to work. So now we have removed the duplicates and sorted that array. And you can see the output here. To remove elements from a set, all you have to do is reference the set you want to remove the elements from. Then use your remove function, and then inside the round brackets put the element you want to remove. So let's run this code, and before we had elements item 1, 2, 3, 4, and 5, we have removed item 5, and when we run this, the output in the console should now just contain items 1, 2, 3, and 4, and it does. So you can see 1, 2, 3, 4. Even though it shows them unordered, it did remove item 5. To count the elements in a set, you can just simply reference the set name, then use a dot and type out count. So you can see in this set we have 5 unique elements. Even though 5 is in here twice, it will remove that duplicate and give us the count of unique elements. So let's run it. And you can see down here in the console, the count of unique elements for set 5 is 5. So for these next two examples, what we want to do is to test to see if an element is in a set or if it's not in a set. One way to do that is to use an if statement and then use your contains function. So in this case, we have used the if statement. We say if set 6 contains element boxer, display this message, else, or if it does not, display this message. And notice that this syntax basically does the same thing as this syntax. The only difference is, in this case, we're first testing if it does contain something, and in this case, we're first testing if it does not. And the main difference is, for the not, you just use this exclamation point, okay? So in this case, we're saying if set 6 does not contain Akita, print this message, else if it does, print this message. So it's basically the same, it's just in this case, we're using the not. So let's go ahead and test this code and run it. For our first if statement, it says yes, boxer is in the set because boxer is right here. And then in this second example, we get Akita is not in the set because we can see that Akita is not in this set. okay? Next up, if you'd like to test a set to see if it is empty, we've put this inside of a print to display. You just simply use your variable name, and then you use a dot, and then you type out is empty. Now we can see this set is empty, so let's go ahead and run this, and we should get back true. And you can see down here in the console, we get back true. Now, if you were to put elements in that set, then you'd get back false. Next up, let's go over a couple different ways that you can display elements of a set as sorted. So here we have our set. One way that you can display those as sorted is just simply to use a for loop. So you say for I in, reference your variable name of the set, then use a dot and type out sorted. Then inside the curly brackets, just use a print to display those elements that you iterate through. And another way that seems to work fine looks like this. So you just reference your set variable name, use a dot, and type out sorted. So let's go ahead and run this. And this is the output from the for loop, and this is the output from set8.sorted. In our next example, let's use union to combine two sets. So here we have set 9 and set 10. Set 9 contains the elements bronze and silver, and set 10 contains the elements gold and platinum. So here we have created a new set, and to combine the elements of set 9 and 10 together, we just use set 9, and then we use a dot, then we use union, and inside the union round brackets we put set 10. So when we use a print to display the elements of set 11, it should now contain bronze, silver, gold, and platinum. Okay, so you can see down here in the console we get the expected outcome. For our next example, we're going to use the intersection function. So once again, we have two sets. Set 12 contains tiger and lion, and set 13 contains the elements tiger, lion, cheetah, jaguar, and lynx. So here we have gone ahead and created a new set, set 14. And to use the intersection function, we reference set 12, then we use a dot, and then we type out intersection, and then inside the round brackets we put set 13. So what you'll notice from this is set 14 will contain only values in common to both set 12 and 13. So let's go ahead and run this. And you can see down here in the console we get tiger and lion. And in a sense you can think of that as where set 12 and 13 intersect, or the elements that they both have in common, okay? In our next example, let's use the symmetric difference function. And what you'll notice from this is that set 17 will contain elements in set 15 and 16, but not in both. So let's go ahead and run this. So remember, set 15 contained elements A, B, and C, and set 16 contained elements A, B, and D, and the elements in common were A and B, but set 15 had C and 16 did not, and set 16 had D and 15 did not. So you can see the outcome down here in the console gives us D and C, and once again those are elements in either but not both. For our next example, let's use the subtracting function, and what you'll notice from this is that set 20 will show elements in set 18 that are not in set 19. So let's go ahead and run this. And you can see our outcome gives us 3 and 1. So again, set 18 had elements 1, 2, and 3. Set 19 had elements 2, 4, and 6. Now notice that the elements in common are 2. And the way we set this up is we typed out set 18 dot subtracting 19, which again will show the elements that are in set 18 that are not in 19, which would be 1 and 3, because 2 is in set 19. Or another way you could think of this is that you're going to subtract the elements in common. So we typed out set 18, subtracting set 19, and once again the elements in common were 2, so if you subtract the elements in common, you still get 1 and 3. Next up, if you'd like to test two sets to see if they have the same elements, all you have to do is use two equal signs. So we can see that sets 21 and 22 have the same elements, and to test for that, we typed out set 21, two equal signs, set 22, so when we print this to the console, we should get back true. And we do, we get back true, we're good to go. Next up, if you'd like to test to see if a set is a subset of another set, all you have to do is type out the set, then type out is subset, and then put the other set in the round brackets. So let's go ahead and run this. In this case, we're testing to see if set 24 is a subset of set 23. And we can see that it is, because set 24 contains action and comedy, and so does set 23. And we get back the expected outcome of true, which tells us that set 24 is a subset of set 23. In this example, we want to test to see if a set is a superset of another set. So let's go ahead and run this. And in this case, we're testing to see if set 25 is a superset of set 26. And we can see that it is, because set 25 contains everything that set 26 contains and more. And we get back true. Now just a quick note, you can use is strict subset or is strict superset to test if a set is a subset or superset but not equal to a specified set. Okay, moving on to our next example. In this case, we're going to use the is disjoint, and the is disjoint tests whether sets have any members in common. Okay? So we have two sets here, set 28, which contains the tree types maple and oak, and set 29, which contains the tree types redwood and pine. We can see that these sets have nothing in common, so when we use is disjoint, we should get back true. Let's go ahead and run it, and you can see we get back true. Now, if we were to add an element, and now these two have at least one element in common, we run this again, now we should get back false. And we do, we're good to go. A few other things that you can do with sets include summing the elements. We have an example of that here. You can also find the smallest and largest elements using the min and max, and we have an example of that here. And then in our last example, if you'd like to turn a set into an array, one way you can do that is to take your set and then wrap it in an array like this. Okay, so we created set 31. Then we created a new variable, and we assigned the array syntax, and inside the array round brackets we put set 31. And then if we go ahead and print this out, you can see down here in the console we get set 31 back as an array. Now you can also hover your cursor over set 31 array, and you can hold down your option key and then click it, and you can see that the type shows array. Okay? So you can see you can do all kinds of cool things with sets. That's all we have for this Swift programming tutorial. We will be doing many more Swift tutorials in the near future. Join us for those, and we'll see you next time.